Welcome to Building Dictionary Comprehensions in Python. My name is Christopher, and I will be your guide. This course is all about dictionary comprehensions. You'll learn how to write comprehensions, how to use filters inside of a comprehension, how to turn iterables into dictionaries using comprehensions, and applying transformations to dictionaries using comprehensions. The code in this course was tested with Python 3.13. Comprehensions were added to Python in 2.7, so pretty much anything Python 3 will be fine for your playing around. Python has a whole bunch of syntactic sugar that makes your code easier to read and write, but could be written using equivalent longer forms. One of these kinds of shortcuts is comprehensions. A comprehension is an inline way of creating a data structure using a nested for loop-like mechanism. This course is about comprehensions for generating dictionaries. To build a dictionary comprehension, you use an iterable, that's a thing you loop over, a target, that's the variable that you're populating from the things inside the iterable, and then a key-value pair construct that is what gets inserted into the dictionary. Additionally, dictionary comprehensions can also include an optional filter so that not everything you're iterating over gets included. Okay, let's get started. In the next lesson, I'll kick things off with a quick review of dictionaries. In the previous lesson, I gave an overview of the course. In this lesson, I'll give a quick review of dictionaries and how you construct them without a comprehension. A dictionary is a data structure that maps values to keys. This kind of structure is also known as a hash, hash table, hash map, or associative array. Python has a dictionary built in, and it's called the dict. Let's say you had a set of things to sell in a store. You could have the things for sale be the keys, and the prices be the values. Then you could look up the pen key to find out that it's $865. It's a really nice pen. Dictionaries are optimized for retrieval. If I had a list of items in the store, trying to find one means searching through the whole list. While with a dict, I'm looking things up by key. The length of time to look something up for a dict is more or less independent of the number of items in the dict. I say more or less because there are some edge cases, but for our purposes, let's stick with they're independent. The reason a dictionary is sometimes called a hash or hash table is because it's based on a hash function. A hash function is any function that maps a piece of data to a slot. The slot, in this case, being where you're going to store the associated value. There's lots of math behind writing a good hash function and dealing with the corner cases called hash collisions, where two different items map to the same place. But you really don't need any of those details to play with dictionaries. Not all things are hashable, and for an object to be used as a key in Python, it has to work with Python's hash function. Most common data types are hashable though, so things like strings and numbers are fine. You're not likely to run into a problem unless you're doing something funky. Let's head into the REPL and review how you construct a dictionary. You use brace brackets to define a dictionary. Here, I'm going to construct a mapping between fruit and their prices. Each key-value pair is defined with a colon. The string apple is my key, with the float 40 cents as the value. I can add more than one key-value pair as part of my dictionary definition by using a comma, like I have here. Orange is my second piece of fruit. Pear is my third. And then I finish the dictionary with a closing brace. Let's look at what I just defined. And you can see the key-value pairs. A quick aside, in the real world, you should never use floats for prices, as funky things can happen as decimals in floating point may not behave the way you expect. Instead, you should use the capital D decimal class. But for the sake of brevity, I'm sticking with floats here. You retrieve a value from a dictionary by using square brackets to reference the key. You can also use the same mechanism to modify a value. My apple is now 45 cents. You can also use this mechanism to add new key-value pairs to the dictionary. Yes, sir, we have some bananas today. For clarity, when I wrote the fruit price dictionary, I split it up on multiple lines, but you don't have to. Here's the result. Everything in Python is an object, and the brace mechanism is just a short form for creating a dict object. You can also create one like any other class. Don't be fooled by the lower case here. Dict is a class, and this is instantiating an object using the arguments to the constructor as the key value pairs in the result. This dictionary shows you that you have a choice. You could buy a Kia or 48.5 pens. So far, I've been creating a dict all at once, but frequently you are going to be adding and changing values as you go along. One common pattern is to use a loop to calculate values and store them in a dict. This dict is going to store the first 9 powers of 2. My loop ranges from 1 to 9. Range 10 is exclusive at the end. And for each number, I'm storing a key value pair of the number and 2 to the power of that number. Let's look at the result. And there you go. You've calculated values and stored them in a dict. In the next lesson, I'll show you how to do that same thing that you just did in a loop, but with a single line of code. In the previous lesson, I reviewed Python's dict class. In this lesson, I'll introduce Dictionary Comprehensions, a single-line way of constructing a dict. A Python comprehension is a bit of shortcut syntactical sugar that allows you to construct a data structure. Both the list and dict types have a comprehension form. Both forms use syntax similar to a for loop, but nested inside the syntax brackets for the respective data structures. So for lists, that's a square bracket, and as you saw in the previous lesson, it's braces for dicts. This is the structure of a dictionary comprehension. I find it easier to read a comprehension from the inside out. The underlined chunk here, starts in the middle, is the same as the declarative part of a for loop. For thing in container, where thing is the variable getting stuffed with the contents from the container. In Python, this process is called iterating, and an iterable is anything that can be iterated over. Member, in this case, is the target of the iteration. The portion here to the left of the loop declares the key value pair that is to be inserted into the dictionary. This is almost always something based on that iterator target in the for. So key and value would be constructed based on member in this particular line. There's another more complex form of dictionary comprehension as well that allows a conditional. The if here is like a Python if statement, and if the condition evaluates to true, then the key value pair gets included. Otherwise, you proceed to the next step in the iteration. Let's head into the REPL and try this out. On the screen is the powers of 2 example from the previous lesson where I used a for loop to create a dictionary containing the first 9 powers of 2. Let's try this as a comprehension instead. Remember how to read this. Start in the middle at the for. For num in range means to iterate over the return result of the range function, which is the numbers 1 through 9. Each value from range is put into num, and then on the left side of the comprehension you have a key value pair. The key is the value num, while the corresponding value being stored is 2 to the power of num. As you can see, this has the same result as the for loop above. This code is more compact than a for loop. It's a tiny bit harder to read if you're not used to it, but it also tends to be faster. Since comprehensions are more restrictive than a general for loop, Python can do things to optimize them. Most of the time, a comprehension will be faster than its loop-based equivalent, but not always. You should always validate. Let's do this again, this time with a condition. Once more, when reading it, start in the middle at the for num part. I'm still iterating over the result of range, which is the numbers 1 to 9. To the right of that is my if condition. If the number is even, that's mod 2 is 0, then the key value pair gets included. If it's not, then it doesn't. On the left-hand side is the key-value pair. This is the same as it was before, mapping num to 2 to the power of num. And there's the results. You can also nest the iteration portion within another iteration portion. Consider a matrix defined as a list of lists. This is my matrix with 3 rows and 3 columns containing the numbers from 1 through 9. If I want to create a dictionary containing the items in the matrix as keys and their squares as the values, I can use a nested for mechanism inside a for mechanism in the comprehension. When reading this, once more, start in the middle, or in this case, a bit left of center, at the first for statement. This time, the for is iterating over each row in the matrix list of lists. To the right of that is a nested for statement, which iterates over each item in the row and puts the result in num. On the left side, you get a key-value pair. The key is num, the item from the matrix, while its corresponding value is its square. And here's the results. Next up, I'll show you some comprehensions you might use to solve specific problems.